Yes, what is the question? When n is 2 to the power of 4, 3 to the power of 3 into 5 to the power of 2, right? Then we need the number of divisors of n. And what kind of a divisors are required? Those divisors which are divisible by 6. Now when n is expressed in the prime factorization as p1 to the power of alpha 1 into p2 to the power of alpha 2 into p3 to the power of alpha 3 so on up to pk to the power of alpha k, where each of this p1, p2, p3s are primes and the corresponding power of each prime number is alpha 1, alpha 2. Then we know that the total factors is, yes, there is nothing but the arrangement of alpha 1 things of similar kind, alpha 2 things of second kind, alpha 3 things of third kind, so on, using any number at a time, right? Then it would be simply alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 into so on up to alpha k plus 1. Now if you remember, why are we using plus 1 here? Yes, the plus 1 is also the additional case of not using any factor of p1, right? Using any number of p1s out of alpha 1 p1s, including not using any one is also included. That's why we get the total factors. But here what is the requirement? What is the difference in this? We are not required to find the total number of divisors. We need those divisors which are divisible by 6. So shall we say, for the divisor to be divisible by 6, what is the condition? Out of the 4 2's and 3 3's and 2 5's, we must include at least 1 2 and at least 1 3. When the divisor has at least 1 2 and 1 3 in it, then the divisor will be definitely divisible by 6, and it can include any number of 5's, right? Then the factor would be definitely divisible by 6. Now what are the different cases of at least 1 2? This would further get into 1 2, or because we have total 4 2's, we might have 2 2's in the combination, or we might have 3 2's in the combination, or we might have 4 2's in the combination. Similarly, when we consider at least 1 3 out of the 3 3's, then what are the different cases that arises? Yes, there could be 1 3 in the combination, or there could be 2 3's out of the 3 3's available, or there could be all the 3 3's included. Now similarly, when we write any number of 5's, there are 2 such 5's are available, then what are the different possibilities? Yes, we may not include any 5 in the combination, because any number here, the number 5 need not be included in the divisor, or there could be 1 5's included in the factor, or all the 2 5's which are included are also there. Then the divisor formed will be definitely divisible by 6. And if you remember, the other important result, R things can be selected from n similar things. Yes, how many ways can we select? In only one way, right? This is also another important result. So therefore, the required divisors of n which are divisible by 6 are, how many will be there? Yes, 2's can be used in, how many ways can we select 1 2 out of 2 2's? By this result, it can be done in one way. How many ways can we select 2 2's out of 4 2's? That can also be done in one way. Therefore, 2's can be contributed in 4 ways. And how many ways can at least 1 3 can be selected in 3 3's? Yes, that can be done in 3 ways. How many ways can any number of 5's can be selected from 2 5's? That can also be done in 3 ways. Therefore, the total number of divisors which are divisible by 6 would be 36, and the correct option for the given choices is B, which has 36 in it, right?